there's something special about the slant height in relation to the radius and in relation to the actual height. So we have this radius right here, and we have this height right here. So if we know the distance of the radius, and we also know the distance of the height, what theorem can we use to find the distance of the slant height? This is a throwback to Unit 1. What theorem can we use?
Pythagorean.
The Pythagorean theorem, okay? So let's know, so we can only use the Pythagorean theorem if we have a right triangle. But since the height is straight up and the radius is flat, it makes a 90-degree, this is a 90-degree angle, and therefore we can use the Pythagorean theorem, okay? So we have to find the two legs and we have to find the hypotenuse. Which variable would be the hypotenuse? Or what is a hypotenuse? What is a hypotenuse? Kevin says is the longest side. I agree with him. The hypotenuse is the longest side. So which side is the longest side? R, H, or L? Is so it could be a little bit tricky to see. We are going to note the L to be the longest side. In a right triangle, another way to denote the hypotenuse is it's across the right angle. So it's the longest side and it is across the right angle, okay? So this L is the hypotenuse. Actually, this is hypotenuse, which is L, okay? So the Pythagorean theorem is that we take both legs. We take one of the legs. Leg, and we square that, plus the other leg squared, equals the hypotenuse squared. Both legs squared added together equals the hypotenuse squared. The hypotenuse is L, okay? The longest side is the slant height L. So the other two, the radius and the height, are the other legs of our right triangle. So leg 1 would be the radius. So the radius squared plus the other leg squared, the height squared, equals slant height squared, or L squared. And this formula using the Pythagorean theorem is pretty important because if you know two of the distances, you can always find the third distance. If you know the radius and the slant height, you're always able to find the actual height. And it's true if you know 2 out of 3, you can always find the third one.